that. That's your job. Okay, so we're going to find the area of a regular hexagon inscribed in a circle of radius 12 inches. All right, what's a hexagon?
8 sides.
How many sides?
8.
Hex. Hex would be 6. Octagon would be 8, right? So, guys, we have a lot to do. All right, so here's my circle. We've established that a hexagon has 6 sides, so I'm going to go ahead and make 6 little hash marks around my circle. And then I'm going to connect those hash marks. And there is my hexagon inscribed in a circle. Nobody's grading your picture, so don't waste a bunch of time making it perfect. Just get it up there. There it is, the hexagon. The radius is 12 inches. So all of these would be 12 inches. I'm not going to label all of them, but would you agree with me? All of those are 12 inches? All of these triangles, even my picture isn't very good, but all those triangles are congruent. So if I want to find the area of the whole shebang, I could actually find the area of the triangle and then multiply it by 6. Right? Okay. So let's look at the triangle. Any one of them, it doesn't matter. I'll look at this one. That side's 12 and that side's 12. Do I know anything else about that triangle? Think about it now. Think about it. Jacob?
You gotta like split the triangles in half in order to like find the area of each one.
Oh, you mean drop an altitude in there?
Yeah.
Okay, I could. There's an easier way. But I could. I absolutely could. You're right. I could. You know something about that triangle. Think about it now. How big is
The
the
inside
side?
angle is 60 degrees.
It is 60 degrees. And how do we know it's 60 degrees? And why is your camera off? How do we know this is 60 degrees? How do you know it's 60 degrees?
360 divided by 6.
Exactly. All of these around here, guys, add up to 360, and they're all equal, right? So 360 divided by 6 is 60. So that's a 60-degree angle there. Obviously, if this were an octagon, that wouldn't be a 60, right? That would be 360 divided by 8. All right, now take a look at that triangle. All right, who took good notes last time? That triangle is like really, really cool when it comes to finding area, because look at what we have. We have 2 sides in the included angle. How do we find the area of a triangle when we have 2 sides and the included angle? That is the angle that's in between them. 1/2 side times sine of included angle. So in area problems, there is no better situation than what you have right here, because the area of a triangle is 1/2 side sine. Those of you that were here, we derived that formula, but we said we're never going to go through that again. We're just going to use it 1/2 side sine. So I can type that in on my calculator. But remember, that isn't the answer to the question. That is the area of the triangle. So then I'll just hit times 6. And my hexagon has an area of 374.12 square inches. Is that okay? So this could have been a decagon, an octagon, a pentagon, anything, and the strategy would have been exactly the same. Okay. Next one. A parallelogram has sides of 18 and 26. So 18 and 26, that's a parallelogram, remember that. And an angle of 39 degrees. So this angle right here is 39 degrees. Do you agree with me? This is 26 and this is 18. Okay. Find the length of the shorter diagonal. So there's two diagonals, obviously, in this quadrilateral. And the shorter one would be right here. Now, I know you might be getting all excited because you see side, side, sine of included angle, but we're not doing area. That would be for area, right? 1/2 side, side, sine, that's area. I want the length of that purple segment. So to find the length of a side of a triangle, we either use the law of sines or the law of cosines. So which do you think is appropriate? Sines or cosines? Gotta be cosines. And it has to be cosines because in order to use sines, you have to have a pair. Remember that? The way it's set up, the proportion? So I have this angle, but I don't have this side. I have this side, but I don't have this angle. I have this side, but I don't have this angle. There's no pair. So I can't set up my law of sines proportion. I can set it up, I just can't solve it. So now I guess I'm going to do the law of cosines. So remember the law of cosines? On one end, you're going to have the cosine of your angle, which is 39. On the other end, you're going to have its opposite side, which is x squared. And then who remembers what's in the middle of this big long formula?
Clear and arguable about what Fitzgerald is saying in the great the novel itself.
26 squared plus 18 squared minus 2 times 26 times 18 times cosine 39. So in the middle goes just a combination of these other two sides. So 26 squared plus 18 squared minus 2 times 26 times 18 times cosine 39. Now luckily, the variable is being solved for. I'm all done. I just type it in. Only part we sometimes forget about this, whoops. Only thing sometimes we forget is to take the square root of the end. Don't forget that what you are typing in right now is x squared. So we're going to square root that. I got 16.51 feet. Does that match you? Anybody else get that? Okay, that's pretty easy. All right, let's see what the next one says. Surveyor's calculations. Tony, oh wait, before we go on. Let's look at this problem just in case this would ever happen to you. So we got this thing, this parallelogram. What if we wanted the longer diagonal? We wanted the shorter one, so it worked out great. But what if we wanted the longer one? Please don't assume this has been cut in half. It has not. Remember from geometry, the only time the diagonals bisect is in a rhombus. This is not a rhombus. So we don't know anything about these two angles, except they add up to 39. What's this angle? 180 minus 36, so don't forget, or 39. Don't forget that. So this one would be 141 if I subtracted right. And then you could go ahead and use your law of cosines, right? Using the 141 instead of the 39. Okay? These angles are always going to add up to 180. They're congruent. Opposite angles in a parallelogram are congruent. Yeah. These two triangles are congruent. They're exactly the same. All right, so here we go. Tony must find the distance from A to B on the opposite side of the lake. Okay. He locates point C. Okay. Okay. Then he measures the angle at C, finds the distance of AB. All right, so let's look at that. The picture is drawn for you, and this is actually a very common way to measure distances that aren't handily measurable. Obviously, you can't measure from one side of the lake to the other, so they're using some trigonometry. Because this is on land, he can measure that. This is on land, he can measure that. So now he can find that distance right there. Okay? Well, what do you think?
We did like the same thing we did previously?
Pardon me?
We did the same thing we did previously?
Probably. Which thing are you talking about?
The cosine.
Law of cosines, absolutely. Anytime you want to find a side or an angle of a triangle, you got to use the law of sines or cosines. Unless it's a right triangle, you have to use the law of sines or cosines. This problem isn't usable. The law of sines isn't usable because I don't have the right information. So I'll do the law of cosines. On this side will be x squared, and clear out here will be cosine 78. What will be in the middle? Yeah, 860 squared and 175 squared minus 2 times 860 times 175. In the order of any of that doesn't matter. So I did 860 first, you could do 175 first. Makes no difference. Go ahead and type it in. And then, oh, that's a huge number. Don't forget to take the square root. Did you get 841.22 feet, maybe? Yeah. Everybody okay with that? All right, now the last one, there's no picture. You're going to have to come up with your own picture, so let's see if we can do that. Two airplanes flying together in formation take off in different directions. One flies, all right, so let's put the airport right here. There's the airport. One flies due east at 350 miles an hour. So here's one airplane going due east at, I'll just make a note here, 350 miles an hour. The other flies east-northeast. Okay, so let me put my compass here. Now remember what east-northeast means. Northeast, this is northeast, and this angle would be 45. Would you agree with me? Now, east-northeast, this one's also 45. East-northeast, remember, you can be on the north side of northeast, or you can be on the east side of northeast. So would you agree that this is the vector that's east-northeast? And since that splits the 45, these are 22 and a halves. And that guy is flying 380. So I'm just going to make a note here. That's 380 miles an hour. How far apart are the two airplanes Does that make sense? How far apart are they? After they separate, assuming that they fly at the same altitude, for 2 hours. Okay, so what does that tell me about the length of this vector? Remember, the guy's going 350 miles an hour. So the length of this side is 700. And this guy's going 380, so the length of that one would be 760. Everybody okay with that triangle? All right, law of sines or law of cosines? Going to be cosines again because I don't have enough, or I don't have the right information. So x squared over here, cosine 22 and a half, because ultimately that was the angle that was between these two. And then 700 squared, 760 squared, minus 2, 700, 760. Cosine 22 and a half. Here we go. Don't forget to take the square root. I got 290.85 miles. Anybody match that? Probably wouldn't hurt you to be typing those in, just to make sure you can. All right. Well, the other day I gave you some extra practice problems. It was just 2 little pieces stapled together. Would you get that out? There's all kinds of interesting problems. Let's look on the front side where it says extra practice 5.5, 5.6, and there's 5 typed problems. Let's do number 3. That looks interesting, and that will give us some practice with some different skills. So we are looking at this right on the front side. There's somebody's yard or something. Looks like this. This is 105. This is 18. This is 24. This is 28. And our job is to find the area of that. Does anybody have any ideas about how to find the area of that? It is not like, it's a quadrilateral, but it's not one of your like normal ones. So there's no formula for it. We're going to have to do some figuring. What do you think? Rory?
This might be a stretch, but can you break it up into 3 pieces?
You know what? I don't know that that's a stretch. We could break it up into however many pieces we want, but we really only need to break it up into 2. Because if we drew in a diagonal, we'd have 2 triangles, wouldn't we? And we know how to find the area of triangles. Now, we may not have exactly what we need. We may have to do a little law of sines or cosines or something to get what we need. But once we got triangles, we're pretty home free. So I would suggest, it really doesn't matter, but I would suggest that you split it this way, because this is a right triangle, and right triangles are easier to deal with, only because we have we have the Pythagorean theorem, for example, we have SOHCAHTOA, we have things available to us that we don't have in regular triangles. One more time though. See that angle's been split? It has not been bisected. I have no idea how big these are, so when it comes time for me to use those, I'm going to have to figure it out. Do not assume it's been split in half, it hasn't. All right, so help me out here. Can I find the area, let me call this triangle 1, and this will be 2. Can I find the area of triangle 1? 1/2 base times height, kids, is right there. So the area of triangle 1 will be 1/2 18 times 24. 1/2 base times height. Now, if you want to use your new formula, you can also say 1/2 side, side, sine of included angle, which would be 90. Now the sine of 90 is 1. So these two things are exactly the same. So this is 1/2 base times height. This is 1/2 side, side, sine. And they equal the same thing. So what is that? Let's go ahead and get that number because we're going to need it. We're going to find the area of the whole triangle, or the whole quadrilateral. So this one's 216. So we'll save that. We're going to find the area of that one and add it. Okay? Now let's look at the top triangle. I literally know nothing about it except that this side's 28. Is there any other information I could find out about it? Tyler?
Pythagorean theorem with 18 and 24.
Absolutely. So this right here, the hypotenuse of this right triangle, I can just do the Pythagorean theorem for, and then I'll know that side also. So 18 squared plus 24 squared. Oh, that's 30. That worked out nicely. So that's 30. Now I want you to think about this for a second. You should be getting excited about this. You now have two sides of the triangle. If we could find that angle right there, let me mark it in red. If we could find this red angle, then wouldn't the area of that triangle just be 1/2 28 times 30 times sine that? So now that means we got to find that angle, okay? So do you have an idea about that?
Like 90, 60, and 30 for the first triangle, and then.
Okay, now wait. You're making some big assumptions, Jacob. Not every right triangle is a 30, 60, 90. If the sides were like, if this was 18 and this was 18 root 3 and this was 36, then they'd be in the right ratio and I'd have a 30, 60, 90. Okay, so no. But I can find the angles of that triangle. Could I find, let me mark it in purple, or in green, I guess. Could I find my green angle? I'll call it X. Can I find that angle right there? Oh, shades of chapter 4, people. Yes, you can find that. The tangent of X equals 24 over 18, for example. I could also say the cosine of X equals 18 over 30, or I could say the sine of X equals 24 over 30. Pick a function. And then how do I find X? What do I type on my calculator? Second tangent. If this is my equation, I second tangent. So second tangent, 24 divided by 18. I got 53.13. Now, that is not the one we wanted, though. The one we want is the red one. And how will we find the red one?
5 minus.
Yep. So 51.87. Now, can I find the area of triangle 2? 1/2 30 times 28 times sine 51.87. did that right. I got 330.38. And then what do I do to get my final answer?
But we
Add it to the 216. So our final answer is 546.38 square feet. That problem is like the hexagon problem we did. We didn't know how to find the area of the hexagon, so we split it up into triangles. So that's what we did here. We just split our shape up into triangles. And then finding the area wasn't too bad. All right, let's go to prequest number 2. I try to keep track of what we've done. So that's on the very back side. And let's look at problem 5. So I have a triangle that's called MNR, and M is 16, N is 18, and R is 20. I'm on prequest number 2, the very back page, back side. And we're going to find the largest angle of that triangle.
the opposite one.
So it's going to be the one, it's going to be R, right? Because it's across from the biggest angle. Okay? Now, to find an angle or a side, okay, take your little packet, the very back side. How do we find an angle or a side of a triangle? We must use either the law of sines or cosines, unless it happens to be a right triangle, and then I have the Pythagorean theorem and stuff. But this is not a right triangle. So which is going to be appropriate, sines or cosines? Got to be cosines. Remember, to use sines, to use the law of sines, you have to have a matched set. You have to have angle R and side R. You have to have angle N and side N. If we do not have a matched set, which we don't, then we got to use the law of cosines. You said we're going to find R, so out here on this end, it's going to say cosine R. And then on this end, it's going to say 20 squared. So cosine R on one end, 20 squared on the other end. What's going to be in the middle then?
18.
Yep, 18 squared plus 16 squared minus 2 times 18 times 16 times cosine R. This one is not as easy to type in because the variable is kind of buried at the end. So what are kind of the steps? This might take me a couple of steps to get my answer. What might I do here to get this ball rolling?
Simplify.
So figure out what all these squares are. So 400, 18 squared, is that 324? I can never remember. Yep, 324, 256, 2 times 18 times 16. Remember, these are all multiplied together, so that's 576 cosine R. So that's a good way to start. So we just squared all the stuff that needed squaring, and we multiplied all these numbers together, the ones that are hooked to the cosine. All right, now what shall we do? Add those two together, yeah, so what is that? 400 equals 580? Is that right? Minus 576 cosine R. Now be careful, you might be tempted to subtract these, but you can't, right? Because this one's got a cosine. So what are we gonna do? Yep, so negative 180 equals negative 576 cosine R. Divide, so we have 180 over 576. The negatives cancel, so I'm just not even going to write them down. The negatives cancel out. Don't waste time reducing that fraction. I know it reduces, but that's not the answer. The answer is the angle. How are we going to find the angle? We need to know what R is. Inverse cosine, second cosine, 180 divided by 576. So the largest angle of the triangle is 71.79. And that's all we wanted. Just find the biggest angle. What if we'd have wanted the smallest one? We'd have done the same thing, right? Except the smallest one would have been M, but I would have set it up exactly the same way. Okay, everybody all right with that? All right, let's look at the next one. Just to make sure that you draw the picture right and you know what you're looking for. So we have an angle, or triangle, I mean, that apparently has a Q in it, and an R in it, and an N in it. Oops, N. Alright, so then N is 81, and side R is 19. So make sure, however you oriented your picture, and really where you put the Q, R, and N, that's not what's important. Put them wherever you want them. But make sure that because this is side R, it's going to be between these two angles, right? And your job is to find Q, which is right here. So that's what we're looking for. When we find the side of a triangle, we use the law of sines or cosines. This is going to be the law of sines. Because how many of you noticed that you have angle R? I didn't give it to you, but you got it, right? Because we know the angles of a triangle add up to 180. So that angle is 51. Now, look at what you have. It's the first time today we've had that pair. And when you have that, then you know you can use your law of sines. So sine 51 over 19, always start with your pair, whatever your pair is. And then
I think I left my water in here.
Okay.
Got it.
So then, sine 48 over Q. Does that look all right to everybody? All right, let's cross multiply. So Q sine 51 equals 19 sine 48. Now remember, you're solving for Q, so you're going to divide by sine 51. So Q will equal 19 sine 48 over sine 51. Will this be one I'll do second sine on? Nope, just straight type it in. We're not looking for an angle. So 19 sine 48, close those parentheses, divided by sine 51. Side Q is 18.17. All right, everybody keep up with that? Okay. All right, let's see. We just did one like number 4. We did one like number 3. We've done yours. Let's look at those ones at the top. We don't need to do all of those, but let's do a couple of them to refresh our memories about how we determine the number of possible triangles. Remember, this is only an issue in triangles that look like this. Let me get that first one drawn. So I have angle C is 18, side C is 4, and side H is 3. that configuration of information is different than what I had over here. Remember in this one that we just did, this was the given. That was the stuff you were given. That's angle, side, angle. No problems. Angle, side, angle. Congruence postulate. This information is angle, side, side. That's the one that causes us problems. So when you have that information, angle, side, side, there's the potential for multiple triangles or no triangle at all. To figure it out, we're going to go ahead and use the law of sines. So sine 18 over 4 equals sine h over 3. So cross multiplying. Remember, sine h is your variable. How will I type this into my calculator? Second sine. Yep, your variable is sine h. That means you have to second sine, inverse sine to get rid of that and have just h. So inverse sine 3 sine 18, close those parentheses, divided by 4. I got an answer, did you? Sometimes we don't, which means the triangle is impossible. But I did get an answer. I got 13.4 degrees. Do you remember what you have to do then? We're not going to finish solving that triangle. That isn't what we're doing. We're just figuring out now if there's another possibility. We've got one. Is there another one? Who remembers how to do that? How do we figure out if there's another possibility? I draw it again, just the given parts. And here's my angle H. Is there another angle H? Well, if there is, it's 180 minus that one. So that would make it, can't believe how lazy I am, 166.6. Now I stand back and look at that. Does that triangle make sense? No, it doesn't. Why doesn't it make sense? Because these two are already more than 180, and I haven't even figured out what that one is yet, right? So this triangle doesn't make sense. So how many triangles are possible in this situation? One. Yep. Let's try one more of those. And then let's do C. Let's do problem C. So C is 73 degrees, side C is 16, and side H is 17. All right, so there's the given. Everybody get it drawn okay? Oh, Declan?
Can I use the restroom super quick?
Sure. All right, so what's our setup going to be? How many triangles are possible? Sine 73 over 16 equals sine h over 17. Is that what you said, Grace? Yep. So sine h. Now, again, whenever your variable is sine h or cosine x, you've got to do the inverse. So inverse sine, 17 sine, 73 close parentheses, divided by 16. Uh-oh. Did you get an error? What does that mean? No triangles are possible. The calculator will just tell you there's no triangles possible. None at all possible for that. Okay, so having now, let's see, looked at that. All right, what else do we have? let's look. Let's look at, let's just stay on this page. We don't have much time, so I don't want to change to different page. Let's try number 4. We've already done one like it, but let's make sure you guys can do problem 4. So it's another parallelogram. Sorry, I'm drawing for you. And that's 6, and that's 122, and that's 14, and this is A, and this is C, and we're gonna find AC. All right, you should be able to whip this out pretty darn easily. You got everything you need. What's your thought process? Remember, opposite sides are congruent, opposite angles are congruent. What's your thought process? Law of cosines. And Grace, what's that law of cosines gonna look like? I know it's gonna be x squared equals what?
6 squared plus 14 squared minus 2 times 14 times 6 times the cosine of 1.2.
Perfect. Type it in, square root it, and that's the answer to that question. Does anybody have a question about that? Don't forget to square root it. 17.92. So AC is 17.92. Now I need the area of it. Who's got a thought there? Oscar, you got a thought on the area?
Half base times, yeah, base times height.
Well, half base times height would be awesome if I had the base and height. But a base and a height requires a 90-degree angle. I don't have that. So what? The sine of 122, what else? Okay, let's stay real focused here. The area of a triangle is 1/2 side times sine of included angle. And then we just type it in. There's no work, really. I mean, that's it. That's the work.
Hey, you take out that 1/2, you get to do
Okay, this is going to be the area of the triangle. So Tyler is saying, well, what if I just didn't type in the 1/2? Because I'm going to double that anyway, right? Absolutely. So side times sine would be the area of the whole parallelogram. Yep. That is exactly right. So either way you do it, you're going to get the area of the parallelogram to be 71.24. Is that right? All right, let's grab number 3 real quick. Find the perimeter and area of a regular nonagon inscribed in a circle of radius 12. What's a nonagon? 9 sides. So I'm going to draw my circle. I'm going to put 1, 2, 3, 4, 5, 6, 7, 8, 9 dots around it. Picture doesn't have to be perfect. Nobody cares. The radius is 12. I need to find the area and the perimeter of this. Well, area is easy. We've talked about area already. Can I find the area of this triangle?
360.
I need this angle, and it's going to be, what is that, 40?
Yeah.
Is everybody okay if I just write 40 in there? There's 9 of them, adding up to 360. So the area of the triangle is 1/2 12 times 12 times sine 40. But there's 9 of the triangles. So I have to multiply that by 9. I got 416.53 for the whole nonagon. 416.53. Everybody okay with that? No issues? We could whip that out in no time. Okay. What about perimeter? Now, perimeter means this. This is the perimeter of the nonagon. How will I go about finding that? I need to find a side, like this side, right? And then times it by 9. So I just got to figure out, Jacob, if that's a law of sines problem or a law of cosines problem. And actually, it could be either one. I would just jump in with the law of cosines because it's ready to go. But because the triangle is isosceles, what do I know about these angles? They're equal. And since that one's 40, these two have to add up to 140, which means they're each 70. So if you wanted to use the law of sines, you could, because that triangle's isosceles and you can get your angles. I would just use the law of cosines. Personally, that sines will work. Just remember to times it by 9, because you want the whole perimeter. David?
Can you do radius times radians?
Oh, okay, great thought. Radius times radians would give me the arc length, not the perimeter, no, not that segment length. Now, David, the more sides a polygon has, the closer those two things become. So just think about it. If this thing had 30 sides, then these would be so small that they approximate the arc, so that actually could be used, but it's going to have some inherent error in it, okay? Also, you need to change that to radius. Okay, all right. You guys still with us? Okay, we're done for the day. See you later.
Thank you.
Bye.
Oh, Miss Ford,
What?
is there a certain time that you'd want to meet with me or something to just make sure that I'm kind of for the bus? Or am I good?
I think you're going to catch yourself up. Everything's on video, and we just kind of reviewed everything here. And we're going to review a little bit more. But if there's something you have a specific question about, why don't you come to office hours? I always have the Zoom on during office hours. Okay? All right, I'll see ya.
But thank you.
Okay, look out. It's time to spray. Gotta get this thing going here.